Abdul Rahman University of Science and Technology. B.S. Abdul Rahman University, Vandalur, Chennai 48, formerly B.S. Abdul Rahman Crescent Engineering College.
My name is Sriram. Welcome to this video presentation on data. Now, there are some terms that we come across in computer science every day. Data, information, data management, analysis, mining, analytics, and science. This video aims to give examples for each of these terms and explain them so that the learner can understand them better. So, what is data? The simplest example for data, simplest explanation for data is that data is a set of raw facts. What is a fact? A fact can be true or false. What is raw about the fact? What is raw about the fact is that it is given listed without any context. A fact can be a student score, a grade, a letter grade, a subject name, a birth date, an image, a sound, a video presentation. Without the context, these by themselves don't give any useful information. A set of marks or scores, say 70, 80, 90, a set of numbers written on a sheet, a set of numbers expressed in a sheet, by itself doesn't make any meaning. So data can be an image, sound, or text. By itself, it doesn't carry any meaning. It can be single valued, multi-valued, and so on. Now, for data to be meaningful, it needs to be analyzed or processed. Information is processed data. Information is analyzed data. The diagram shows that we have to do some processing. We have to do some processing here so that the data can be meaningful. Now, what are examples of information? A collected set of scores of students in a subject over 2 tests gives an idea of whether the scores are increasing or decreasing. The average of weight of 10 people gives us an idea about the overall weight of the pack. So data is the input and information is the output. We generate large amounts of data in our everyday lives. We generate large amounts of data in terms of our weight, our distance traveled, our kilometers traveled, our heights. We generate large amounts of data every day. Now, these data items are shopping habits, what we purchase at a store, what we want, what we hear, what we like, what we see, who we interact with. All these are distinct items of data. For these items to be meaningful, it needs to be converted into information. And information is the need of the hour, not data. So, the example here shows a simple example. This is the Reef Floor, that is the raw material, that is data. It goes through various processing stages to become information. The roti that we generate is our information. The next example gives a set of dates, and these set of dates become meaningful when we collect them and collate them and add the context that these are the list of universal holidays. These are the list of universal holidays. Similarly, a value 5 by itself does not show any meaning. But if this is derived as the number of days that Joe has worked in this week, this gives an information. A set of employee ages by itself does not give any meaning. The average ages of all the employees in our organization gives a value of how young or how old the organization is. Now, data needs to be managed, needs to be represented. We need data for deriving the information. So data needs to be created, acquired, accessed, stored, retrieved, updated, protected. And these steps together form the data management steps. These steps together form the data management steps. Data management is different from data analysis in that in data management, we transform one item of data, a category of data, into another category of data. The input is the data, output is again the data. So we transform them, we can retrieve them, we can store them. Now, data analysis is the process of extracting information from data. The process of extracting information, deriving using useful information, analyzing information, or processing information is called data analysis. Data analysis can be in the form of a simple query. For example, we have a set of marks of students. We can write a query to determine how many students have scored more than 90% in that class. Say the number is 5. The simple query that executes and gives the number of students who scored above 90 or below 50 is a simple query. We can show the marks in the form of a graphs with various medians represented. So these again report shows some useful information. Similarly, we can perform statistical analysis such as the average of the class average, the standard deviation, and so on, and more complex operations like data mining. The goal of all these steps is to derive useful information. The goal of all the data analysis steps is to derive useful information. Now, the next term that we are looking at is data mining. The definition is that data mining is the process of analyzing large data sets to determine unknown information. There are three distinct words that are important here. One is the analysis. So since we say analysis, it's a process of taking a large set of data and turning it into useful information. The second part is the operative word large. Now, when we do an analysis on small data, we can derive that easily. But when the size of the data set becomes large, it becomes very difficult for us to identify the patterns in the data. Now, for example, if we want to compare the scores of two set of students, when the size of the data is larger, for example, we correlate the size of all set of students of all the students in the state, it is very difficult for us to find out a pattern whether the scores are increasing, decreasing, and so on. So then we need to look at trying to find out hidden patterns in this data. There can be all kinds of hidden patterns in this data. For example, students of a particular region may do well in one subject as opposed to another, and students of another region, there could be a correlation between the availability of textbooks in the region and the scores of students in the region. There could be a pattern between the climate in a particular region and the set of scores in that region, and so on. So what we have is that we have a large set of data. There is a distinct possibility that there are hidden patterns that are there in these large sets of data. The domain that aims to understand and find out this is data mining. For example, again, we have a shopkeeper's information. There are large amounts of people, customers who visit the shop. The shopkeeper found that men generally bought cool drinks with chips and women bought fish with chips more. So as opposed to men, women bought fish with chips more. So this is again a type of data that has been mined from a large set of data. The key here is that these patterns are hidden. The shop didn't start off with the hypothesis that men bought fish more or chips more or cool drinks more, but the shop aimed to look at the buying patterns of its customers, and from that it unearths these items of data. So there's a difference between data mining and data analytics in that in data mining, our starting point is what we don't know. We don't have a hypothesis and start towards that goal. Our starting point is what we don't know. We are aiming to find out hidden patterns on large data sets. Now, why do we do data mining? The size of data is growing every day. The size of data is growing every day, and at a large scale, there could be useful information that we can mine, and all aspects of customer-centric organizations are doing data mining on their customers. Mobile, all organizations that sell byproducts are aiming to mine the customer data so that they can improve their profitability. Now, data analytics is a process. Again, it's another domain that aims to find out insights from the data. But data analytics is also all about building the methods behind the data, building the methods in the models of data. Now, the distinct difference between data analytics and data mining is that data analytics starts off with a hypothesis. We start off with a hypothesis saying, here is a hypothesis. For example, we are looking at the correlation between men buying a particular item along with chips and women buying, and what is the item that men buy along with chips and what is the item that women buy along with chips. And with this hypothesis in mind, we move towards the goal. Now, data analytics starts off with a particular hypothesis. Data mining does not start off with a hypothesis, it starts off with hidden patterns. It aims to find the hidden patterns. To understand data analytics better, let's look at the subdomains of data analytics. Now, descriptive subdomains of data analytics can be called as descriptive analytics, diagnostic analytics, predictive analytics, and prescriptive analytics. Now, descriptive analytics seeks to find what has happened. For example, in a school example, lower scores in a particular subject or lower scores can be what has happened. So, prescriptive analytics, there is a set of school data. Then we say, okay, here is our hypothesis. The hypothesis that we start off with is lower scores. We look at all the scores and we found that in a particular subject or in a particular region, there is a set of lower scores. So, what has happened is, based on the past data, we try to find out what has happened. Now, diagnostic analysis seeks to find out why something has happened. Is there a hypothesis that can explain that? Is there an explanation that can explain that? Is there an item of data that is also linked, that can be linked? For example, lack of textbooks in a particular region. Can this explain, is there a correlation between lack of textbooks in a particular region and the scores in that subject? So we then look at other subjects where there are lack of textbooks and see whether this pattern is repeating. Now, predictive analytics looks at the likelihood of an outcome. Now, we look at the likelihood of a particular outcome. We try to forecast based on the students' score in different cycle tests and so on. We can predict their score in the end semester exam. We can predict who all will fail in an end semester exam and so on. So, predictive analytics is just a forecasting mechanism. We have past data. We build a model to model the past data. We can use probabilistic models to predict, probabilistic or predictive models to predict what will happen, what is the likelihood of a particular outcome. Prescriptive analytics looks at the overall ecosystem. Now, we model the overall ecosystem, we model the complete system showing the outcome of each decision and then recommend the best outcome. Now, we look at the overall ecosystem of students getting scores. What are the factors? Whether it is low text, whether it is the availability of textbooks, whether it is availability of best teachers, whether it is availability of working long hours, working short hours, and so on, and then try to maximize the outcome. If we say we want to increase the scores, we want to have best education, we want to achieve the metrics that are set out by the state, and so on. So we model the entire system. We have tools that can model the entire system, show the effect of each recommended step. For example, increasing the number of textbooks that are available. What is the pros and cons? Moving some best teachers from one region to another. Whether we move teachers from one region to another, but what about this region? What will happen? Will the scores go down? Is there adequate replacements available in this region? And so on and so forth. Multiple variables can be modeled in the system and the outcomes can be predicted, and from that the desired solution can be got. So this is the domain that we call as prescriptive analytics. These are examples of data analytics. The next term that we all look at is data science, and this is a term that has been there for the past 50 years, since the early 60s. Now, data science is analogous to computer science. When we say data science is the process or the science behind understanding how data can be transformed into information, and from the initial transformation analysis methods to statistical methods to predictive methods, it governs a large set of domains in computer science. It amounts a large set of domains in computer science, from machine learning to neural networks to predictive analytics to statistical methods. A large set of, from pre-processing, large set of methods in computer science come under the data science umbrella. Now we examine the relation, and we see that data science is the all-encompassing term. It is the all-encompassing domain. Data science is all about how data can be transformed, how can we explain this transformation process, what is the method, what is the entire discipline of computer science that focuses on that. Data analysis is about transforming information, deriving, acquiring information. Data analytics is a part of data analysis. Data mining is a small subpart of data analytics. So to recap, data is raw fact, information is processed data, information is got from data through analysis, mining, analytics. Data science is a broad term for the combination of all the methods that arrive at insights from data. Thank you for watching this video. If you have any comments and questions, please post them in the link below. Thanks.